Welcome, this is Dr. Amanda Rackinson-Zapke, and in this tutorial we're going to focus on hypotheses. In this tutorial you'll learn how to write a well-written testable hypothesis for your research plan. In quantitative research, the primary goal is to test a theory. To determine if a theory has the ability to explain or predict or describe, you conduct some type of experimentation or observation to test your inference derived from the theory. For example, a general inference based on research may be that community increases learning in a distance education classroom. Maybe this theory has been tested in higher education, but it hasn't been tested in a K through 12 environment. Therefore, you want to test it in a K through 12 environment. In order to test one of these inferences, or to test this inference, you need to express it in operational terms. That is, you have to formulate a hypothesis, just like we talked about research questions and you had to express a research question in operational terms. You need to express a hypothesis in operational terms. So for example, if we want to test the inference community increases learning, we may say that students' high scores on a community scale will be highly related to good grades in a distance education course in a K through 12 environment. Now, before we go any further, let's go ahead and define a hypothesis. A hypothesis is really an educated guess that can be either supported or refuted through experimentation or observation of some sort. If the hypothesis is supported, evidence exists that supports the theory. So in the example that I just provided, if we find that there is a statistically significant relationship between grades and community in an online classroom in a K-12 environment, then we have supported the hypothesis. If a hypothesis is refuted, then the theory is not supported. If there is no relationship between those two variables, then our hypothesis is not supported and the theory is not supported in the K-12 environment. Now, the importance of a hypothesis in quantitative research, there's really three primary purposes of a hypothesis in quantitative research. The first is really to provide the researcher with a relational statement that's directly testable. So you want to make sure that a hypothesis says this is what I as a researcher am testing. It provides a direction for the research to go, and it provides a framework for reporting and interpreting the findings and making conclusions. Now that we understand what a hypothesis is and what it does, let's talk about what a well-written hypothesis looks like, or the characteristics of a well-written hypothesis. First of all, you clearly state the expected relationship between the variables. So you're going to say there will be a relationship, or if you're going directional, the two variables will be highly correlated. There will be a difference between these two variables. So you state what you expect. And you state those variables very clearly and operationally, and we'll talk about that more in a few minutes. You need to make sure that the hypothesis can be evaluated, that it's testable, that the variables that you're defining can be observed, they can be measured. A hypothesis is founded in the problem statement, and it's supported by the research. What I mean by that is you are testing some type of theory either with a new population, in a new environment, you're extending a theory. You need to make sure your research question aligns with your research hypothesis aligns with your research question. Every research question that you pose has one or more hypotheses that align. And we'll look at examples of that in a few minutes. And finally, even though you want your hypothesis to be very clear and very specific, you also want to make sure that you state it simply and concisely. Now let's take a look at different types of hypotheses before we actually look at examples of these hypotheses. There are two types of hypotheses. There are research or alternative hypotheses, and these are simply statements about what you as the researcher expect in the relationship between or among the variables that you're studying. So that you have a research hypothesis. So for example, I expected in the first example that there would be a high correlation or a strong relationship between course grades and sense of community. So the research alternative hypothesis is state, this is what you state as the researcher, this is what I expect. There's also a null hypothesis, and this is truly what you are testing whenever you do statistical analysis. And a null hypothesis is a statement that states that there'll be no relationship or no difference between or among the variables under study. Now, these are the two types of hypotheses. It's also important to recognize here that research hypotheses can be stated as directional or non-directional, just like your research questions. So again, a directional hypothesis, just like a directional question, says there will be a specific expected relationship in one direction. So you'll see a high correlation, an increase or a decrease. Again, your research question and your research hypotheses need to align. So if you state a directional question, you need to state a directional hypothesis. Again, remember when you're using direction, in a question and a hypothesis, that needs to be well supported by the literature. Again, I don't often recommend directional hypotheses or directional questions unless there's really, really strong support that we've seen a theory established over time and it's always a positive relationship. So I'm going to say it's a positive, I'm expecting a positive relationship or a direction between the variables. Now, then we also have the non-directional, and remember, non-directional states that you expect a relationship, but you don't specify the direction of that relationship. So there just simply will be a difference, or there will be a relationship. Again, your research question and your hypotheses need to align. And while we're talking about this, let me also remind you that your choice of a non-directional or directional hypothesis then directs the type of analysis you're going to do, whether it be a one-tailed or a two-tailed analysis. Now let's take a look at example research questions and how you can write aligning hypotheses. Here is an example question. Let's say as the researcher I pose the question, will there be a difference in the level of responsibility exhibited by oldest children and youngest children in a family? So I want to know, is there a difference in the level of responsibility based on basically birth order between the oldest and the youngest? Just as an FYI, as we're talking about research questions, can you tell what kind of research design this researcher is using? If you note, the independent variables are not being manipulated. I'm asking about difference. So in this specific question, if I was the researcher, I'd probably be doing a causal comparative design. But our focus in this tutorial is questions and hypotheses. So an aligning research hypothesis, remember the research hypothesis states the expected relationship. The expected relationship here is there will be a statistically significant difference in the level of responsibility exhibited by the oldest children in the family and that of the youngest children in the family as measured by the behavior rating profile. The behavior rating profile of just operationally defined level of responsibility. Let me also point out a few other things. I stated there will be a statistically significant difference. So I have a non-directional hypothesis. And again, this is a research hypothesis. I'm stating what will be expected. As you note, the research hypothesis is a little bit more specific than the research question. The next thing I'm going to write is the null hypothesis. In a dissertation or a thesis, oftentimes you write the question and then you write the related research hypothesis and then null hypothesis. Some chairs or mentors only require the null hypothesis, so sometimes you'll just see the null hypothesis. Remember, the null hypothesis states there's no relationship between variables. So here, the null hypothesis is there will be no statistically significant difference in the level of responsibility exhibited by the oldest children in a family and that of the youngest children in the family as measured by the behavior rating scale. Again, there'll be no statistically significant difference. Let me stop for a moment and talk about no statistically significant difference. You note that I didn't say there just will be no difference, but I said statistically significant. A hypothesis, remember you test a hypothesis using inferential statistics. So you're looking for a statistical difference, not simply a difference. There may be a difference between scores. Maybe the youngest children, let's say the behavior rating profile. Let's say the behavior rating profile has scores that range between 0 and 35. And let's say the oldest children on average score 34 and youngest children on average score 32. We can say there is a difference, but what we're concerned about with quantitative research is a statistically significant difference. So did the alpha level reach 0.05 is what we're concerned about. So when you're stating hypotheses, and I'll reiterate this in a few slides, you need to state there is no statistically significant difference. Let's go ahead and look at one more example to make sure that we have this. Let's say I, as the researcher, pose the following question. Will the level of social skills of college students diagnosed with ADHD increase as a result of being involved in an interpersonal relationship group? My more specific research hypothesis, says there will be a statistically significant increase in the level of social skills of college students diagnosed with ADHD who are involved in an interpersonal relationship group as opposed to those college students diagnosed with ADHD who are not involved in an interpersonal relationship group, and again, as measured by the FIRO awareness scales. As you can see, the research question is stated more generally. The research hypothesis is stated more specifically. It's very, very testable. You know what variables are being studied. So the independent variable is the type of group that college students with ADHD are involved in. And there's two levels of that group. There's no group, and then there's an interpersonal relationship group. It's clearly stated what the dependent variable is, and that's a level of social skill as measured by the FIRO awareness scale. The relationship that is expected is that the students involved, it's a directional relationship between variables. So I'm stating a directional research hypothesis that the students who are involved in the group are going to have a higher level of social skills than those that are not involved in the group. Let's take a look now at the corresponding null hypothesis. The corresponding null hypothesis is this. There will be no statistically significant increase. Remember, a null hypothesis says there's no relationship. There will be no statistically significant increase in the level of social skills of college students diagnosed with ADHD who are involved in the interpersonal relationship group as opposed to the college students diagnosed with ADHD who are not involved in the interpersonal relationships group, again, as measured by the FIRO awareness scale. So as you can see, the research hypothesis, the null hypothesis, and the research question all align with one another. Let's talk a little bit more specifically about posing different hypotheses and how many hypotheses you need. Let's look at some rules for writing hypotheses. Let me highlight, first of all, 3 rules or 3 points that I've already stated, but I just want to make sure that you caught them as we were talking about these examples. Number 1, in the hypotheses examples, note that the hypothesis is a lot more specific than the research question. Sometimes they're almost identical because the research question is stated very, very specifically, but it's really important that you state the hypothesis specifically. And this brings me to the next point. It's important that it's specific, the variables are specific, so that the hypothesis is testable. It should be very, very clear what you are testing. It should also be very clear whether you're looking at the difference between groups or looking at the relationship. Again, going back to research questions, if you ask about a relationship in a question, you should then ask about a relationship between variables in your hypothesis. So the terminology that you use in the research question that reflects the type of analysis that you're doing and type of research design that you chose to use, that should be reflected not only in the research question, but then also in the research hypothesis. So your hypothesis should be very specific and it should be testable. Also remember, we use the term statistically significant, either difference or increase, because simply saying difference or increase is not enough. We're looking at whether or not the variance is statistically statistically significant if it reached a statistically significant level. So remember to use the word either significant or statistically significant. Make sure your hypotheses align with your research questions and that they are written in testable form. Now let's talk about how many hypotheses you need to pose for each research question. If you remember, I said you need at least one hypothesis, research and null hypothesis, for each research question. But really the number of hypotheses needed is based upon the number of variables that you're studying. So if your question asks about one independent variable and one dependent variable, you need one null hypothesis. Let's go back and think about the examples that we just looked at. We had one independent, one dependent, and one null hypothesis, and then one research hypothesis. Let's look at the second example. In the second example, we had one independent variable, and that was the type of group that a college student with ADHD was involved in. Either they were involved in the interpersonal group or they were not involved in the interpersonal group. That was the independent variable, and it had two levels. So we had one independent variable. We then had one dependent variable, and that was the level of social skill measured by the FIRO awareness scale. So we only needed to pose for that specific research question. We had one independent, one dependent, so we only needed to pose one null hypothesis and one research hypothesis. But what happens when we have multiple independent variables? Let's take a look at that. Let's say that a researcher or you are interested in looking at two independent variables and one dependent variable. So in the ADHD example, let's say that we want to add the independent variable of gender. So we're interested in, is there a difference in social skills based on not only the type of group that a student's involved in, but also their gender? We then need to pose three hypotheses. We pose two main effect hypotheses and one interaction effect hypothesis. Because what we're going to look at first is there an interaction between the two independent variables, gender and the type of group that students are involved in? We're then going to look at the variables independently, and we're going to look at, is there a difference between the gender, and is there a difference between participation in group? So if we have two independent variables and one dependent variable, we have three null hypotheses and then also three corresponding research hypotheses. Let's look at another example of this. In this example, the researcher is asking, will there be a difference in college students' sense of community based on the type of distance education course they're enrolled in and their gender? So here you can see there are two independent variables, the type of distance education course, and there's two levels to that, synchronous and asynchronous. The second independent variable is gender, and again there are two levels here, and it's male and female, and we're examining one dependent variable, sense of community. Let's start with null hypothesis 3. The first hypothesis that the researcher is going to look at is an interaction hypothesis. He or she's going to look at the interaction between the two independent variables. So the null hypothesis would be stated as this, and as you'll note, there's a typo here, but it'll be stated as, there will be no difference in sense of community among students based on the type of distance education course and the gender of the student. So this specific hypothesis is looking at the interaction effect for both independent variables. Then the researcher will also look at two main effect hypotheses or null hypotheses, one for each of the independent variables. So hypothesis 2 states there is no difference in sense of community among students based on gender, so that's the gender main effect. And the second one, or the first one listed here, is there will be no difference in sense of community among students based on the type of distance education course, and this would be type of distance education course main effect. So the researcher poses one research question with two independent variables and one dependent variable. Thus, they need three corresponding hypotheses. And these three corresponding hypotheses will then be tested using inferential statistics, specifically a two-way ANOVA. And a two-way ANOVA looks at the interaction effect And it also looks at the main effects. So it looks at when you run it, let's say like in SPSS, you're going to get the interaction effect, and you're also going to look at the main effect, and you're going to have F ratios for each of those. So really, then there needs to be a null hypothesis that these null hypotheses reflect that you're going to do this researcher, not you, this researcher is going to do a two-way ANOVA probably. Let's look at what happens if we have more than two independent variables. Let's say, for example, you have three independent variables. If you have three independent variables and one dependent variable, you're going to need 7 null hypotheses and 7 research hypotheses. Because you have 3 independent variables, you're going to pose 3 main effect null hypotheses and 3 research hypotheses. So think for a moment, let's say you had type of distance education course, gender, and ethnicity. You would state a hypothesis for each of those. Then you would write 3 first order interaction hypotheses. And what I mean by first order is you would write a hypothesis for each combination of those variables. So you would write one for ethnicity and gender. You would write one for gender and type of course, and then you would write one for ethnicity and type of course. You then would have one second order interaction hypothesis that considered all 3 hypotheses. So each time you increase your independent variables, you increase the number of main effect hypotheses and first order hypotheses that you're going to write. For the most part, you're not going to have more than probably 3 or 4 independent variables, and that's a lot of independent variables, because remember, every time you increase your independent variables or your dependent variables, anytime you increase any type of variables, you have to increase your sample size in quantitative research. Now we've talked about independent variables, let's take a moment and talk about dependent variables. The rule for dependent variables or multiple dependent variables is a little bit different. And the only time, this is really important, the only time you combine hypotheses for dependent variables is when you plan to examine 2 or more correlated dependent variables. That is, that there has been shown in the research that there is a relationship between the dependent variables. So when you have multiple dependent variables and one independent variable, you always write a null hypothesis and a research hypothesis for the linear combination of those variables. And then you write a hypothesis for each dependent variable on its own. So let's say you had 3 dependent variables. You'd write a hypothesis for each of the 3 dependent variables, and then you would write a hypothesis for the linear combination of those 3. Unlike the independent variables, you don't have the multiple interaction hypotheses. You're just looking at the linear combination, and then you're looking at the each dependent variable by itself. And if you think back to statistics and you think about how a MANOVA is reported, that's what you're doing here is a MANOVA. So you'd look at the F ratio, and then you would look at the post hoc tests to determine which dependent variables are significant. Let's make this a little bit more concrete and look at an example. Here we can see the researcher posed the following question. What is the effect of participation in the Math 2.0 program on second grade students' math motivation scale scores? Now, the scale that's being used to measure math motivation has 3 correlated subscales: external, introjected, and identified regulation. And this specific researcher, let's say, wants to look at all 3 of these dependent variables. So, based on the rule we just discussed, this researcher is going to pose 4 hypotheses. So they have 1 research question and 4 hypotheses because they have 3 correlated dependent variables. The researcher is going to first pose a hypothesis that considers the linear combination of the 3 variables or the entire motivation scale. So the first hypothesis that's proposed is there is no difference in second grade students' mean scores on the math motivation scale based on the type of math program they participated in. Another way to write that would be there will be no difference in students in the linear combination of students' scores on the external, introjected, and identified regulations subscales based on the type of math program they participated in. So actually naming all 3 dependent variables. Since this is one scale, it's also acceptable just to identify the scale. Then you need to write, this researcher needs to write a hypothesis for each of the dependent variables individually. So the researcher is going to say there is no difference. And if you can note here, what's the error? What's missing here? What word? Statistically significant. Remember, we're not just looking for a difference, we're looking for statistically significant difference. So there will be no statistically significant difference in second grade students' introjected mean score on the math motivation scale based on the type of program participated in. So that's the first independent variable. The second one is the identified regulation. So there'll be no statistically significant difference in second grade students' identified regulation mean scores based on the math motivation scale based on the type of math program they participated in. And then the third one, in our fourth hypothesis, the third dependent variable, fourth hypothesis is there will be no statistically significant difference in second grade students' external mean scores on the math motivation scale based on the type of program that they participated in. So as you can see, there are 3 dependent variables, 4 hypotheses, one that considers the linear combination and one for each of the dependent variables. Now to this point, we've looked at hypotheses that focused on independent and dependent variables. Most likely the researchers were doing some type of group comparison study, a causal comparative study, or an experimental study, and probably even more specifically a true experimental study, because none of the hypotheses reflected any control variables or any pretest. Remember, in a quasi-experimental study, you have a pretest most of the time. So you can control for the selection threat to validity. So if you have a pretest or you're going to control for some variable, that needs to be reflected in the hypotheses. You need to add something such as while controlling for gender or while controlling for the pretest. So that's another important rule to remember. However, I also want to talk a little bit about hypotheses for correlational studies. In a correlational study, you have variables of interest or predictor and criterion variable, and we'll talk more about that when we talk about variables. But the rules that we just examined hold true in a correlational study. As the number of variables increase, the number of hypotheses increase. So if you're looking at, let's say, one variable, the relationship between one variable to multiple variables, just like in our dependent variable rule, you're going to have a hypothesis for the linear combination of the multiple variables and how they relate to the one variable. And then you're going to have a hypothesis for each of the individual variables, how they relate to that one variable. So the rules that we just looked at hold true for correlational studies too. Now that we've looked at examples of hypotheses and discussed rules in writing hypotheses, good, strong, testable hypotheses, it's your turn to develop both research and null hypotheses for your methodology section or for your research plan. So I encourage you to read the handouts, use the information in this tutorial, and write your hypotheses. Remember, make sure you have hypotheses that align with each research question. And remember, each research question needs at least one hypothesis. But depending on the number of variables you may have multiple hypotheses for each of your research questions.